Good morning all. Let us see today the root locus construction. In the previous class, we have seen the root locus construction for the real pole. Let us see today the construction for the imaginary poles, and also the zeros is also given. See, for the problem is construct the root locus for the unity feedback system with g of s, which is given as k into s plus 9 divided by s into s square plus 4s plus 11, right? So as per the previous procedure, let us see one by one. So first step, what we need to do is we need to determine how many number of locus. For that, I need to calculate how many number of poles, how many number of zeros. Okay, regarding the poles, we have one pole at 0, another pole is a complex pole, one is lying at -2. You need to solve this equation, s square plus 4s plus 11 as per the quadratic equation. You need to solve minus b plus or minus root of b square minus 4ac by 2a. Using that equation, if you solve, you will get the poles at this point, right? That is given as -2 plus or minus j 2.64. So one pole is at -2 plus j 2.64, another pole is at minus j 2.64. So totally there are 3 number of poles. So that is why I have given here as maximum of p is 3, z is 1. So what is the maximum of 3, 1? That is 3. So this shows that the number of locus is 3. Now second step is we need to calculate how many asymptotic lines are there. Asymptotic line is p minus z. So now there is a 0 is also present in this problem, right? That is s is at -9. So that is a 0. So therefore I need to calculate p minus z. So that is 3 minus 1 is 2. So the number of asymptotes are 2. Now I need to calculate how many number of angle of asymptote. So if there is a 2 asymptote, that means I will be having that many number of angles. So therefore, what is my q? My q is 0, 1, etc. up to p minus z minus 1. P minus z is 2. 2 minus 1 is 1. So I need to calculate q is equal to 0, q is equal to 1. When I substitute q is equal to 0, the angle is plus or minus 90 degree. When I substitute q is equal to 1, the angle is plus or minus 270 degree. So there are 2 angles present, right? So then at the fourth step, what we need to calculate is the centroid. So what is my centroid formula? So that is summation of real part of poles minus real part of zeros. This is only real part you need to consider. So what is the pole? Pole is at -2 plus or minus j 2.64. What is my real part? Real part is -2. So that is -2. So same another pole is at -2 minus j 2.64. There also my real part is -2. And what is my 0? 0 is at -9, but it is minus of real part of zeros. So that is why you need to put plus here, right? Plus 9 divided by p minus z. P minus z is 2. So therefore 2. So my centroid is 5 by 2, that is equal to 2.5. Now I need to calculate whether the breakaway will exist. So actually I have given that there is no breakaway. Let us see, right, from the root locus. See, for example, right here I have drawn the root locus like this, right? So that is this is my real axis sigma, this is my imaginary axis j omega. Okay, so what is my pole? Pole is at 0. So this is one pole where I told you, already I told that at which the point of value of k is 0. So this is one pole, and another pole is at that is your that is complex pole. Complex pole is -2 plus or minus j 2.64. This is plus 2.64. This is minus 2.64. So these are the two complex poles. Now let us see how many number of locus are present. As we know, the number of locus is 3, right? So 3 means, and also based on the construction rule, I told you that the root locus will always start at pole, end at 0. Okay. So if you look at this line, real axis line, from after this pole at 0, so at all points when I am looking at back, the number of poles lies on the real axis is odd. So therefore this line, right, this locus line will exist, right? So the locus from this pole to the 0 will exist, right? This is one of the root locus. That is why I have plotted as root locus 1. So that means this will start at here and end at the open loop 0. So I told you that this is one of the point that root locus will start at pole and end at open loop 0, right? So there is a open loop 0 at minus 9. So therefore this is a root locus, right? Exist. So therefore there is no chance for breakaway on the real axis. This is one of the root locus will exist. So no breakaway will happen, right? Breakaway will happen only at the case where my root locus will start at pole, right, and the end is also at pole, right? So if the locus will exist between the two poles, if suppose if the two poles are here and the locus will exist, means there the locus will break, right? Here there is no chance for break because it will start at pole, end at 0. Okay, so therefore that is why I have taken this as no breakaway. Okay, then so that means one root locus I have found out. What about my two more root locus? So therefore that root locus will exist between at this point of complex poles. So before that you plot this centroid. What is my centroid? Centroid is at 2.5. So therefore at 2.5 I have to draw as an angle of 90 and 270. So this is my 90 degree and this dotted line indicates this is 90 degree, right? This is 90 degree, this is 270 degree. So this is 270 degree. So this is my asymptotic line. So that shows that the root locus will depart from this pole, right? This pole and cross the imaginary axis here and it will follow this asymptotic line. This is an asymptotic line. So this will also follow the same asymptotic line. Similarly, another root locus will exist at this depart from this complex pole and it will travel like this and it will also go and follow this asymptotic line. This is my asymptotic line and it follows this asymptotic line. So therefore what I need to calculate is, so therefore as we know that there is no root locus, there is no breakaway, right? So this is my root locus 2, right? This is my root locus 2. This is my root locus 3. This is my root locus 3. Okay. Now I need to calculate what is the departure, right? So two things we need to calculate. One thing is what is the angle of departure from these two poles and where it intersects in the imaginary axis. Okay. Let us first discuss about the departure. Okay. What is the angle of departure? So angle of departure is theta d, where theta d is said to be 180 degree minus angle made with poles, right? Where you are calculating. See, I want to calculate the departure from this pole. So therefore, this pole I need to connect with all other poles and zeros. So this is the pole I want to calculate the angle of departure, right? So this pole I need to connect with this pole and this pole I need to connect with this pole. This pole I need to connect with 0. So I need to connect the respective pole, all other poles and zeros. Then I need to calculate the respective angle. Okay. So now let us calculate the angle made with poles. So angle made with poles means this is a pole with pole, right? This is also pole with pole, another pole. So this angle I mark it as theta 1. This angle I mark it as theta 2. So these two are complex poles, right? So therefore this angle is exactly 90 degree, right? No need to calculate. This is exactly 90 degree, that is theta 2. So theta 2 I have written as 90 degree. Okay. Now what is this theta 1? So this angle I need to calculate. I can calculate only if I know this angle. So therefore I can put theta 1, right? This theta 1 is the total 180 degree, right? Total 180 minus this theta, right? This theta. That is where I have given here. Theta 1 is 180 degree minus theta. What is my this theta? This theta is, see, take this triangle. So this is one of the triangle, right? One of the triangle, wherein which this theta I can calculate as tan inverse of, this is opposite side. This opposite side magnitude is 2.64. So this is 2.64 and the adjacent side. This adjacent side is 2. So this is 2.64, this is 2. So I can say that what is this tan theta? Tan theta is opposite side is 2.64, adjacent side is 2. So therefore tan inverse of 2.64 by 2. Now you calculate, so subtract, right? Subtract this from 180, so it becomes 127.1 degree. Theta 1 I have calculated. Okay. This theta 2 I already told that it is theta 90 degree. Similarly, I need to calculate what is the angle made with 0. Okay. So that is theta 3. What is the theta 3? Now I need to take this triangle, right? This triangle I need to take. Then I need to calculate this theta. This theta means again it is tan inverse, right? Tan inverse of what is my opposite side? Opposite side remains same, right? That is 2.64. What is my adjacent side? So my adjacent side is, this is 9, right? This is 2. So what is the difference? 9. So this is 9, this is 2. The difference comes as 7, right? So this is 7. So I need to put 7. So this, don't take negative signs and all. This is only the value alone, right? What is that height? What is this height value? That is 2.64. So that is my opposite side. What is the adjacent side? What is the from start from -9 to -2? So what is -9 to -2 is the difference is 7. So therefore it is 7. So 2.64 by 7. So theta 3 is tan inverse of 2.64 by 7. That is equal to 20.7. Right? Now I need to substitute all angles in this departure calculation. So that is nothing but 180 minus, this is angle made with poles. So I will take minus outside. And what is my theta 1? And theta 1 is 127. So 127.1 degree. What is theta 2? 90 degree. Right? Either you can write it separately also. That means you need to write minus 127.1 minus 90. Otherwise you can add and then subtract. Okay. Then the important thing is, here you should not subtract, here it is add. So this is addition of angle made with zeros. So what is the angle made with 0? That is theta 3. What is my theta 3? Theta 3 I have calculated 20.7. So therefore you need to add 20.7. Total when you add and subtract this, I will get minus 16.4. So this is 16.4. I need to take the one when you calculate, being it is a complex pole, right? When this comes as minus 16.4, this comes as plus 16.4, right? Therefore, I can make it as plus 6 point. That is your theta angle of departure for this pole. I have calculated angle of departure for complex pole is, that is theta d is equal to plus 16.4, right? So you can calculate one departure is sufficient, right? Now you need to have with your protractor and then mark this angle of 16.4 and then draw the root locus line like this, right? Similarly, you take a protractor and then mark the angle as 16.4 and then draw the line like this, right? This is the two root locus. So with this we have calculated the departure and plotted the root locus, right? The final step, we need to calculate where my root locus will intersect at this imaginary line to travel similar to this asymptotic line, right? It has to travel similar to asymptotic line, travel to k at infinity, right? Meaning that there the zeros will present, right? So when at k is equal to infinity, there will be some zero. Similarly, here also this root locus will end at k is equal to infinity, where there will be a zero, right? So these two root locus will end at infinity, right? Only one root locus will start at this pole and end at 0. But remaining two root locus will start at this pole and end at 0, which is at k is equal to infinity. Similarly, this root locus will also start at this point and end at k is equal to infinity, where the zeros are present. Okay. So final step, we need to calculate the intersection at the imaginary axis. What we need to do is, we need to write the characteristic equation for this given system. What is the characteristic equation? The characteristic equation is 1 plus g of s and h of s is equal to 0. So 1 plus, what is my g of s? Being unity feedback, I need to substitute h of s as unity and g of s this equation, right? This I have substituted. Then you cross multiply. This is my equation. So then you convert into powers, right? So therefore this becomes s cube plus 4s square plus 11 plus k into s plus 9k, that is equal to 0. Now I need to find out, right, the intersection, no? So I need to construct a Routh array, right? So now I need to construct Routh-Hurwitz, right, array, where in which I need to plot s cube, s2, s1, s for 0. So the magnitude is 1 and 4. So 1 and 4 here, so you need to substitute like this, and then 11 plus 1, 11 plus k and 9, 11 plus k and 9. Okay. So this is 9k. Then you need to calculate the respective rows. So this shows that the last row, this is 9k. So I need to make the system to be stable, right? So if I want to make this system to be stable, then this 9k should be greater than 0. That indicates that k should be greater than 0, right? So therefore k is greater than 0. That I have found out. So then comes to the s power 1 value. So now this value I need to calculate. That is 4 into 11 plus k divided by 4 minus k should also be greater than 0. So if it is to be greater than 0, this implies that what should be the value? This you need to solve, right? This you need to solve for k, and this k should be less than, right? This is also to be greater than 0 means my value of k should be less than 44 by 5. Okay, so that is equal to 8.8. So this is 5, right? 44 by 5. So that is equal to 8.8. That is the value of k. Now when we substitute, right? So this 8.8 here, this value becomes 0. Okay, when you substitute 8.8 here, k value, this whole thing becomes 0. So this is also 0, this is also 0. Then that means I need to write an auxiliary polynomial for this row, right? So what is my auxiliary equation? So this auxiliary equation, so here you need to assume, right, k is equal to 8.8, right? This row indicates that k is greater than 0. This row indicates that k should be less than, right? K is greater than 0. So k is greater than 0, but it should be less than 8.8 to maintain the stability. Okay, this is the stability value. For to maintain make the system to be stable, I need to maintain the value of k to be greater than 0, but it should be less than 8.8. So I need to assume this 8.8 here. When I assume 8.8, this also becomes 0. So then therefore I need to write an auxiliary equation for this row. So that row is 4 into s square plus 9k. Now I know value of k, no? That is 8.8. So therefore I need to substitute k is equal to 8.8. So that is equal to 0. Now this becomes s square is equal to minus 19.8. So when you take a root of this becomes plus or minus. This becomes plus or minus j into 4.44, right? 44. That is the imaginary, where it cuts in the imaginary axis. That is plus j 4.4. So this is plus j 4.4. Here I have written this is plus j 4.4. Another thing is minus j 4.4, right? Minus j 4.44. So these are the 2 points that lies in the imaginary axis. That is the intersection at the imaginary axis, right? So that is, so as a whole, right, this as I have told that there are 3 root locus. So one locus will start at this pole and end at minus 9. That is one root locus. Another root locus will start at this point, that is minus 2 plus 2.64, and depart from here, right? Depart from here with an angle of 16.4 and intersect at the imaginary axis at the value of plus j 4.44. That is my root locus 2. Okay. Now root locus 3 is another pole is at minus 2, minus 2.64. So from here it will start and it will go to this point, right? That is angle of 16.4 degree, and then it will travel towards the asymptote and it intersects at the imaginary axis at the point of minus j 4.44, and it will travel towards the 0, which is located at infinity, and it follow the path of the asymptotic line. So this is the root locus number 3. Thank you.